Thank you for the opportunity today so I can present our paper, which is entitled Design of Reinforced Concrete D-Beam based on SNI 2847-2019 and analyzed using STM and CAST. First, please let me introduce my team first. They are Muhammad Aswin, Sonny, and myself, Tony, as the representative of my team. Our presentation outline today comprises in 8 parts. The first is backgrounds. In general, foundation, pile caps, bridges, and shear wall, and the other buildings have utilized reinforced concrete deep beams. The design of the deep beam generally cannot use the Bernoulli hypothesis because the stress distribution is not considered linear. So one of the best known and most widely used methods is the Strut-and-Tie method. Because of its superiority and simplicity for analyzing disturbed areas, this method has been adopted by many design regulations, including SNI. SNI recently added the Strut-and-Tie method for deep beam design in its code. Although the Strut-and-Tie has been widely used, the design itself takes a lot of time in determining the strut and tie's dimension, so that developing and using a software based on solution can help the design. And from the description that I told before, we can conclude 2 problem statements. They can be seen in the slide. And from the problem statement, there are 2 objectives that we aim for this paper. The fourth part is design of the beams based on SNI. And here are some of the terms on designing deep beams by using SNI provision codes. The detail of the specimen itself can be seen from the picture shown in the presentation slide. Before we start on predicting the Strut-and-Tie model, we need to know the stress flow of the deep beam. So we analyze it first by using the Lusas 14, and here is the result of the analysis. So from the stress flow, we can assume the truss model under the applied load in model 1, and the second model, which is figure B, was proposed by the previous researcher. The procedure for designing the reinforced concrete deep beams, which adapted from SNI, can be explained as follows. The first is defining the geometry of truss model, and the second resolve the assumed truss model to define the member force. And in this case, we are using the SEP 2000. And here is the result from the analysis by using SEP 2000. Next, we check the bearing capacity and then design and verifying the strut and ties capacities. The picture shown in the slide is the width of strut and tie for both models. After that, we need to design the reinforcement for tension areas and body reinforcement. And the last step is check the strength of nodal joint and anchorage. And here is the final design of reinforced concrete deep beams for both models. After we designed the models, we need to analyze it. First, we analyze it by using Strut-and-Tie method. Analysis was carried out on both truss models. The deep beams, which have been designed by the SNI provisions, and then analyzed by the Strut-and-Tie method to obtain the force ratio. The force ratio itself is the quotient of the force acting with the section capacity. If the force ratio obtained is less than 1, it means that the STM model can be applied to the DPIM, which was designed by using SNI provision codes. And from the table 1, we can see the average result of force ratio for model 1. And here is for model 2. After that, we need also to analyze it by using cast. Analysis was also performed using the CAST program. CAST is a program which is developed by University of Illinois to facilitate design of basis of the Strut-and-Tie Model. And in brief, analysis of deep beam using CAST can be summarized in 5 steps shown in the slide. First is setting up the workspace and then constructing the models, then obtaining Strut-and-Tie Model forces, and then defining and assigning properties. And last is checking the stresses. So here is the result of the analysis by using CAST for each model. So from the analysis result based on STM and CAST itself, we can compare the average force ratio according to them. And from table 3, we can see the result. The result shows that the force ratio of all strut and ties members meets the safety requirement, which is less than 1. It means that the stress models are applicable to design the reinforced deep beam using SNE provisions. So from the analysis and design, we can conclude 4 points as we can read from the slide. So here are the references we use on this paper. And yeah, that's the end of the presentation. Thank you for your attention.